Welcome everybody. This is our weekly OPI lifecycle provisioning technical working group. Today we have a couple of agenda items. We have Reza from HP. Very good discussion on the boot sequencing. So we'll hit that today and continue our boot sequencing discussion. Before that, I want to just quickly hit a new topic that came up last week regarding the local discovery of DPUs on the network. So we will spend like 5 minutes on this. This is a discussion from Slack, so let me share the Slack with you. And then we can discuss it quickly. There are a few comments from Vipin and Lee. And I want to hear kind of the rest of the group what you're thinking about, if that makes sense. Okay. Can you see my screen?
Yes.
Okay, cool. So I was looking into the local discovery. The topic, the use case that came in is sometimes we have applications running on the host with DPU inserted into the host. And we do want to configure the DPU from the same host without going to remote orchestrator that sees all the DPUs and stuff like that. Basically, we just want to send a few gRPC commands to that DPU to perform some operation, whether it's inventory, query, or some configuration from that specific host. So basically, if we assume that there is a kind of networking already established, so for example, on physical function 0, we have, physical function as a network device. We have vendors drivers running on the host, so we can do the networking from the host to the DPU over the PCI Express local bus. And the question that came up, how do we discover the DPU, how we see the IP address and stuff? So one of the ideas is, can we do like PCI Express, whether it's VPD, for example, information over PCI Express, we can discover serial number and stuff. We already discussed it previously, but from network perspective, we didn't have any discussion so far. So I just wanted to raise this question and have a short conversation on this. I was looking into, for example, Redfish implementation, Redfish from DMTF, because I know several vendors running Redfish on their BMC, for example. So Redfish from DMTF recommends or mandates using SSDP, local discovery, simple discovery protocol. Avahi Bonjour obviously is using the multicast DNS. DNS service discovery is another popular option. This is just examples of things that I ran in my lab from Avahi perspective of multicast DNS service discovery or SSDP service discovery. And I wanted to hear kind of your opinions on what you think. There is a few comments from Vipin and Lee. Obviously, I'm not going to read all of that. You can do it on Slack. But can we have a short round of kind of discussions around this? What people thinking?
Yeah, so Boris, if I may, if I understand the use case, I haven't gone through the Slack discussion. I will check that in detail later after this call. But the intent is that we will be adding a new IPU DPU based system into the environment, and we would like to discover that IPU DPU based system and build a local site network port-to-port connectivity for that. Is that the correct understanding? Or
yeah, if we're using already established secure zero-touch provisioning method, for example, we discover everything through the DHCP or multicast DNS or IPv6 Slack. We have a centralized location. When every DPUs and APU register themselves, we can pull that information from there. That's one use case. When we started to develop CSI and CNI drivers for Kubernetes, for example, it made sense, instead of deploying things from master nodes, for example, do a local work. The worker nodes wanted to fetch some information or to configure some things locally from the worker node to the DPU that is inserted in the worker node. We know that most of the vendors can provide the network connectivity over PCI Express, not just outside to the fabric, but also to inside the DPU itself to the gRPC servers that is running inside the DPU. So we can communicate, configure whether you allowed or not allowed, whether it's, it's obviously customer choice, right? We see a lot of deployments when host is completely untrusted, so you're not allowed to do that. But for customers that do feel that this is allowed and want to do that kind of information, I was thinking, how can we discover that IP address or even maybe auto-configure the IP address between the host and the DPU locally outside of what we have via external cable 1 gig management or big orchestration system, DHCP running outside or whatever we have in the infrastructure. This is kind of, and maybe you'll say this is useless. Don't worry about this.
So maybe another option, I see Dan Daly has raised hand as well, but if I quickly just share a comment on the available options, I think LLDP could also be another option for discovering and establishing a port-to-port connectivity in the site local network. So I think LLDP can also be one of the possible options for that type of networking.
LLDP running where? Explain the topology and that use of LLDP.
Yeah, so within the system, the IPU-based system or the DPU-based system that makes itself discovered in the topology and establishes the port-to-port connectivity in the site local network.
You said site local network. Okay, so you're talking about using LLDP for directly connected DPUs to discover each other? Or
exactly. Yeah.
Okay, so when they're directly connected, use LLDP because basically they're
so it's like a peer-to-peer connectivity, right? So you are discovering your peer.
Yeah, LLDP is actually quite good for that. Got it.
Then you were patient.
Or were you saying that the
Lee, just 1 second. Then his hands up for a while. So
okay,
no worries. Yeah, go ahead and finish this out. I'll follow up after. Go ahead.
Go ahead.
Okay. Sorry. So were you saying that the DPU is just acting like a switch, so that you could LLDP discover it from the host, LLDP discover it from the network? Just walk the topology. Is that what you were thinking?
Yeah, something like chain connectivity, like a daisy chain connectivity. You have one IPU, DPU server base connected to another one, which is you added it as the newly installed or newly procured system into your network, and that way it will automatically gets discovered as a peer for already existing system.
So if DPUs are directly connected to each other, LDP is a fantastic way for you to identify that the thing on the other side of the wire is another DPU and its properties. If the DPUs are all wired to switches, the switch can discover those as well. And in fact, it could then share the cluster-wide information. The server wouldn't discover its own DPUs via LLDP. This isn't a PCI or a CXL side. There are, those protocols and buses have their own techniques.
But you're right, Joe, but I was really thinking about that use case. You have your PCI Express bus. On top of that PCI Express bus, you're running your networking stack. So my view was how the host can actually discover the DPU that is inserted in the host, unrelated to another use case that DPUs are interconnected directly. But my question was, okay, you have your PCI Express bus, you're running your network stack on top of that PCI Express bus. You actually can communicate from the host to the DPU for management locally over PCI Express. but you don't know the gRPC endpoint. You don't know the port, you don't know the IP address, you don't know the URL. So you need all of that for establishing the REST API. Redfish, for example, uses SSDP. That in that SSDP record, for example, you get like here, you get location, right? You get the IP address, the port, like here, AL. You get the IP address, the port, and the URL of the Redfish server, so you can actually then communicate with that Redfish server and get all the information you need. So I was thinking in that space.
But Boris, that's from the CPU to the peripheral, or from my system to your system?
From CPU to peripheral.
Okay, so we would want to use, okay, so you could use like SSDP. We were talking about LLDP, right? And LLDP, I don't know that you would want to try to port LLDP to a PCI analog, although we could look at, I've never thought about that. That's something we could look at, but wouldn't be my first choice. I would use something that's more natural for PCI personally.
I'm listing options: SSDP, multicast DNS, LLDP, IPv6 Slack, for example, for zeroconf or IPv6 to avoid conflicts. All of those are options. I just wanted to hear different people's opinion how we approach this.
Yeah, I mean, you can have Ethernet certainly traveling over the PCIe interface, and then but I think that the thing that you run into is you either have to define some new TLVs to give you additional information, or you just have to assume that the management IP is the thing that you want to talk to. Like you'll get standard LLDP is just going to give you an IP address of the management entity on the other side, right?
Yeah,
And it's not going to give you credentials or anything.
No, you would
I'm not
define
talking about LLDP, but yeah.
Yeah, you would, in all these cases, you would define the moral equivalent of a new TLV. So in all of these cases, you have, in fact, that's a good thing to define, is what's the set of information that the host OS, host system needs about the DPU in TLV form, independent of the details of how the transport is done. And then the only question is, what's the best transport? And again, I hadn't thought of ever using LDP for PCI analog, but I mean, I guess it's worth exploring if somebody wanted to write up how it would actually work.
So we have Dan and we have Vipin as well. So Dan, go ahead, and then Vipin.
Yeah, I was gonna say, we do this a lot in the with the IPU, is that we even by default, even before it's provisioned, we have a separate NetDev in the host that is independent of the NetDevs for the physical ports. And we've just been calling it a comms channel. So you can put an IP address on that extra port, and then you can send whatever IP, HTTP, TLS traffic you want into that comms port. And that's a dedicated channel directly into the not just the IPU or the DPU, but into the quote unquote infrastructure. So you don't necessarily know where that's going to go on the other side, but you just know that, hey, if I want to ask the infrastructure, I want to connect to the infrastructure and set up, talk to the hypervisor, or set up some configuration for Kubernetes, or or if I just want to go and set up a ACL rule or something, then there's a like a service layer that the application would set up that exposes those functions from the infrastructure.
So I saw the same NetDev implementation in different vendors from DPU perspective.
Okay.
And in most of the implementation, almost all of them, what I saw is DPU comes up with some pre-configured default IP, and then you put the IP in the same subnet or fix your routing tables on the host itself, and then you can communicate between each other, send different commands, and then this is vendor proprietary. So I was thinking we can add on top of that, we can add some kind of either auto discovery or even maybe zeroconf auto configuration to actually, instead of having the statically provisioned IPs between the host and DPU, we can actually have something more dynamic in nature.
Yeah, the separate NetDev is is a little different from that in that it's like a layer 1 connection. It works the same way. You're essentially, going to figure out, the application is going to figure out some sort of IP address to use to talk to the infrastructure, but it's not in the same data plane as the other types of traffic.
I understand, but from application perspective, it's need to pick up the IP address and need to communicate through REST, for example. Let's just assume REST for a second. So
Yep.
it needs to know URL, you need to know port, you need to know credentials, you need to know all this kind
Exactly.
of information. So this thread is about. I was thinking is, can we standardize or something that we can discover and maybe even auto-configure? I agree with you, Dan. This is a separate NetDev from the regular data plane that we will be using afterwards to plug in into, network offloads and stuff like that.
Yeah, and I think that my original point was that usually the protocol of like, oh, okay, how do I connect to my infrastructure? How do I get my IP address? That's usually application specific. So it might be difficult for us to go and dictate exactly how all of that, anything above sort of layer 2 or 3 happens, but we should at least have a standard way to have this, sort of infrastructure NetDev pop up so that you could have your application go and run its discovery protocol with the other side and make that connection. So I think
I do believe we can take it one level up because, for example, for IPUs, you're running, I know, Redfish server inside your IMC cores. So Redfish already responds to SSDP according to the Redfish DMTF spec. So, for example, SSDP could be a good way to discover the IMC from the host, for example, or from the network.
Oh, I see. Yeah, but usually this connection is talking to our ACC cores. That's talking to the application that's running on the big cores.
I understand.
Yeah, it's separate. It's a different level than layer than provisioning. Yeah.
Yeah, I understand. Vipin, you have your hands up.
Yeah, no, I think a separate NetDev is essential. The question is, how do we identify that NetDev? Either we can make it a fixed or standard, way of identifying that device, or that itself could be communicated through either PMC path or some PCI enumeration. Yes, and then once you have that device identified, you can go configure or auto discover IP or auto configure IP address or static configure IP address on it. Question I have for you, Boris, is in this experiment you did you have IP address configured at all, or this whole DNS or MDNS or SSDP experiment ran before that? In other words, was it just a NetDev device on which you ran these things? Because it seems to me like if you have to fetch all these things over the network, you need an IP address. So I think
part of this can be zeroconf. Avahi Bonjour is basically doing two things. First of all, it picks up the random IPs and fixes the collisions on the IP selection. So zeroconf is already providing the first thing for you is to configure the IP address dynamically between two endpoints.
Right.
So that takes care of this. And the second part of Avahi Bonjour is it advertising the IP address to the peer. So it covers two options. SSDP assumes you have already IP address being provisioned and you only advertise your services on that IP address. So you can, we can go with either way.
That's what I thought. Okay, so I think we are talking about 3 levels of discovery in order for host to communicate with DPU, XPU, IPU. First one is identify the NetDev device in a standard way. Second is auto configure an IP address on it, auto configure or some standard way of configuring it. I can describe to you how it worked for us in that manner. And third thing is then discover services on top of it. So just want to decouple the 3 elements and start to attack these ones independently.
But before we thanks Dan for the thumbs up. Before we deep dive, I just wanted to have a group agreement that this is actually an interesting problem to solve, because I felt like it is, and I just wanted to kind of figure out if people think the same. The separate net device, how we configure the IP address, for example, MDNS, and then how we discover the service.
I'll just one last comment, and then I'll shut up. I think it's a valid use case for Kubernetes type of things, or maybe some kind of CNFs running on the host that have trusted entities. For cloud, this is not a valid requirement because not too often you have to be managed from the host. In fact,
Yeah,
host is
externally
handled.
orchestration. Yeah.
Right. So anyway, there is a use case. I think we should chase it. That's my opinion.
Thanks. Okay, so just to close it up, we have identify three sub questions here. First of all, is a separate NetDev, how we identify that. We can use over PCI Express like VPD or something like that, which is come from specific PCI Express function, maybe to identify the NetDev separately, or any other method. Then how we configure the IP address, and the third one, how we discover the services on top of that. And maybe two of the three answers is the same solution. I'm not saying which one. I don't believe we need to give customers too much options, because otherwise we just lose a standard kind of advantage of doing things in a standard way. For example, if we choose SSDP, I don't think we should pursue MDNS and Avahi in addition to that as an option. Dan, you have your hands up.
Yeah, just a quick comment. I like that. I like that layering. And my thought would be that for the third step, where like the service, like if we had the provisioning service, which is just the same provisioning that you could do from the network, from the centralized provisioning controller, if you could just also do that from the host, if that was allowed, then if you already have an IP address into the infrastructure, then you could just use the same mechanism. You wouldn't have to invent something new.
I agree with you completely. The same service would be accessible from the host and from the network. What I think that VPN meant by service is, for example, the port and the URL. For example, in this space, like, okay, you identify the IP address, but what, for example, the port and the Redfish v1 URL that you're using to actually access the server, this could be additional information that is kind of service on top of just a simple IP provisioning. But I understand what you're saying. Yes. Okay, so we already spent on this 20 and something minutes. I really would like for people to kind of put in this Slack or ping me, email, whatever you want, like what is your preferred way. I see some people talking about IPv6 Slack that helps us avoid collisions. And it's a standard way also to configure the IPv6 addresses. And when maybe we can standardize that IPv6 between host and the DPU itself is better one than IPv4, then maybe we don't need the SSDP, multicast DNS, Avahi, and all the stuff, rest of the stuff. But I'm really interested in what you have to say, guys. So post your opinions, and I do want to put it on the vote once we have an agreement, and this is going to be the next specification that we kind of vote on and adopt in OPI, if it makes sense. Okay, I was talking too much. Reza, you can take it from here on the boot sequencing with CSR and UEFI and all that stuff.
Yes, thank you, Boris. I just want to say at the start, I think that the fundamental issue that we have in which we're trying to figure out a mechanism in which the BMC and the BIOS can cooperate in booting a XPU. And the fundamental problem is we don't know how XPUs from different vendors behave. And I think that's something maybe we need to perhaps do a survey to kind of get some consensus in how they behave with regards to how long, for instance, how long after reset is released before the XPU can respond coherently or sensibly to a PCI config request. The issues associated with some of the suggestions in terms of the doing the retries or the option ROM, loading an option ROM, is all of these require the PCIe manager on the XPU to be functional. And our experience is that it takes a long time for that to happen. And if we issue a config cycle to a device that's not responding, then it doesn't respond, and we think the device is not there, and we move on, our BIOS, that is. If in some cases we've seen where the PCIe manager on the XPU responds partially, that is, it will claim a cycle, but not respond to it. This causes what's called a table of record timeout. That is, the processor expects something back within so many milliseconds, but it never comes back, whether it's a retry cycle or actual answer to the actual response to the original config cycle. So that's where I think the fundamental issue is that we need to solve. And on the alternative of not using the PCIe is for the BMC on the host server to use one of the side channels, such as I2C or NCSI, to query the XPU to figure out what's your status. What's your boot status? Are you booting? Are you locked up? What are you booting to? Are you booting to an OS? Are you booting to some maintenance mode? What are you booting to, and what is your boot status? The challenge with that, again, is that needs to be hardware based, and obviously vendors have not collaborated in terms of defining a fixed location where the BMC, the host BMC, can go access a status register through I2C or and then the other thing is, if you're using NCSI, then that abstraction layer on the XPU has to be functioning well enough where it will respond to the BMC. So those are the fundamental challenges that I see.
So we have Ted hands up.
Yes. So Reza, not to take anything. Oh, go ahead. Oh, sorry.
Just before Ted, I wanted to say, Reza, I agree with you that today there is a lot of non-standardization. I just want this group to not be concerned too much about that, because if we can reach standardization, for example, if you say in I2C bus, we need to align all vendors to use exactly the same address, for example, this is, I think, in scope of OPI to do so. We can influence all the vendors that we can agree that the DPUs and APUs will answer on the same address going forward on the next generations, or if it's firmware based, we can definitely do an upgrades and stuff. I just don't want this group to be discouraged by the fact that today, until OPI was formed, the vendors cannot really agree on anything. I think we have an umbrella now to change that. Go ahead, Ted. Sorry.
So Reza, I think the way you articulated the boot challenge is legitimate and appropriate. And I agree that there are some standardization challenges that we need to address, and maybe we need to look at options. But I think that's only a part of the overall problem space. And we shouldn't try and address this in discrete chunks. We need to look at this broader problem space as one, because boot challenges also reflect in install challenges. They also reflect in host side shutdown challenges. So I think we need to address what happens when the host restarts, when the DPU restarts, when we're doing an OS install on the DPU, when we're doing an OS install on the host. What happens when one side or the other side crashes and creates a crash log and starts again? That needs to be the entire problem space we address, rather than just discrete elements of that.
I fully agree with you, Ted, wholeheartedly. Thank you. Yes.
Yeah, I agree with you both, but I think we need to pick one and try to solve it, because otherwise I think it's too big of a problem to solve at once. Definitely, we need to take what Ted is saying. Maybe the bigger space will actually change or influence what we're solving in a smaller space, but I like this discussion on specifically boot sequencing initially and coordination. Ted, you had some comment.
I was going to agree with you that it's okay to start in one place, provided we had the ability to go back and revisit earlier decisions based on later decisions in other areas of the problem space.
Yeah, I agree. So Reza, correct me if I'm wrong. I'm seeing currently the two paths that being pursued. One is, can we do it in-band over PCI Express? And you stated a lot of issues with that. And the question is, can we address those with DPU vendors? Can we really reliably see the PCI Express device either responding or not responding to the cycles, configuration space, all of that? Can we really fix that and standardize on this approach? The second parallel approach or alternative approach is we don't go in band over PCI Express, we do out of band. And then if we do out of band, which protocol or physical connection we're using, whether it's I2C or NCSI or whatever, and can we standardize on how that communication looks like, what protocol we use, SMBus, PLDM, whatever, NCSI 1.2, 1.3, OEM commands, and what the communication looks like, polling or push mode notification stuff. That is correct, kind of high level, Reza?
Yes, but we also need to, I think we also, there's a time element in terms of, you know, some of, we have to be careful that the changes we recommend are compatible with silicon revision in terms of, you know, is it going to be a multi-generational thing before we can get those changes implemented in silicon, and what can we do in sort of firmware as well? And that applies to both cases, either the in-band or the out-of-band.
Yeah, I agree completely. Yeah, we need to be cautious about it. But if we say this is the right method going forward, and we need a new silicon generation to actually fix it, I think we can definitely also discuss it. And I don't want to dismiss it immediately. Yes, this could be maybe a little bit longer term, but I do feel that OPI is not here for, you know, a couple of months and we're done. So we can have the long-term discussions with our DPU vendors. All of them has plans, as far as I know, personally, all of them has plans to continue the line of DPUs and IPUs going forward, and they all working on the next generation things probably as we speak.
I would still recommend a survey to understand how the various XPUs function.
I agree. I put your survey in Slack, so maybe let me share so people on this call who are not monitoring Slack actively. I don't know where my Slack.
And that list was not intended to be comprehensive by any means, or nor final. We can, you know, discuss what actually goes in the survey and maybe prioritize or add more or whatever.
I just copy paste what you mentioned on GitHub, so tagged everybody here. So feel free, people on this call, please take an action item to go and fill some of the answers that you know, like Dan or Andre, Maciej, I see you here from Intel.
Yeah, we'll try to fix this.
Yeah. Derek, Chetan from Marvell, Deepin from your perspective, and Deepin Sando, and Gal or Gal's replacements, whatever in NVIDIA space. Yeah, if you're not monitoring Slack, I think these weekly meetings is a helpful kind of thing. So Reza, can I suggest that we actually create something about these two approaches on GitHub, for example, right? One is in-band PCI Express. We can actually state, instead of comments, we can actually, you know, fill the page with different concerns that you're having with PCI Express. I feel that you have a lot of experience and knowledge in this space, what problems we're seeing today. And the second approach is out of band. We can have a separate page just on this with two kind of approaches, one after another, and then we can all kind of comment and add things into that. And hopefully we can pick one and focus on how to solve it. Make sense? Can I make this action item on you?
Yeah, yes, please.
Okay, so new page, like everybody agree, new page with two approaches, in-band PCI Express, and continue explore that with retries, misconfiguration, devices not appearing, and out of band, which can include NCSI, I2C, USB maybe, right?
Yes, for future generations, USB, correct.
USB for future generations for sure, right? So I think that we have an opportunity to standardize here.
Yes, I'll do that.
Yeah. So Lee, you kind of my expert from Dell perspective, so would really like your help on this as well.
Sure. We're going to do it all in Slack mainly, or how do we want to do it?
You can talk to Reza, you can, whatever is best for you. But eventually I want to see a GitHub page with these two approaches that we have for documentation. In-band versus out-of-band. I can start an empty page, and Reza and Lee, you can add to that.
Oh, that would be great. Yes, thank you.
Okay. So that's on me. No problem. I'll start one now. Okay. Anything else from anybody else? If we don't need to waste our time and complete this meeting, but if any other topics, we can discuss them or just have a rest and meet next week again. Okay, if nobody's suggesting anything, I have just another topic in addition to the local discovery that we started this conversation with. I already started to think, this is from Red Hat mainly, but I was starting to think how we can standardize on APIs, how to deploy containers and pods in the DPUs. Can we actually make a standardization in this space, whether using OCI or different spec for how we can actually deploy containers inside the DPUs? Because this is kind of untouched space that came up a little bit in API work group. So I just wanted to steer, not to have this conversation today, but just think about that. You can start a Slack, you can email me if you have any thoughts. How can we actually deploy containers to the DPUs? We cannot assume Kubernetes is always running inside the DPUs, so that would be easy. But
is there an assumption about the container runtime? Like what container runtime are we
it shouldn't be.
Okay.
From all the abstraction that I saw in Kubernetes with Creo, Run-C, all the different implementations, they all kind of assume that there is no specific implementation that is, best, and they all follow the same kind of standardization API from OCI.
Mm-hmm.
So that's fine. We can adopt that, or we can adopt the Kubernetes abstraction layer into OCI, which is on top of Creo, which is CRI, I think it's called. That's all right. Yeah. So we can think about that as well. So any type of APIs that we feel that will be helpful for us to actually deploy. This will help a lot in the networking Kubernetes space, because, for example, if Red Hat wants to deploy CNI inside the DPU, they asked me if our work group can start thinking about how this actually will look like. So I don't know. I just started to read about different approaches and different abstraction layers. So if people have any proposals, I just welcome this conversation as well. And then I'm not sure if IPDK talked about that, or this is something was out of scope and we want to reiterate it here from Intel perspective or IPDK perspective. But we're definitely interested in your opinion as well.
Yeah, we've kept provisioning out, and that's always been something that we wanted OPI to answer for us.
But please chime in, right? If you have ideas and topics, please chime in. Okay. Okay. So thank you for your time today. And if no other topics, we can finish this call and go work on our action items. Thank you.
Thanks, everyone.
good.
Bye-bye.
Thanks, everyone.